So see now, next numerical is the plates of parallel plate capacitor have an area of 100 centimeter square and are separated by a 3 millimeter. The capacitor is charged by connecting it to a 400 volt supply. So calculate the electrostatic energy stored in the capacitor. So A question, and B question is, if a dielectric constant of 2.5 is introduced between the plates of the capacitor, find the electrostatic energy stored and also change in the electric energy stored. Okay, so here solution. So initially what the data they have given, the plates of the parallel plate capacitor has an area. So area value they have given. What is area value? That is 100 centimeter square. So write it in the SI units. So 100 into centi means 10 to the power of minus 2 whole square. It will become 100 into 10 to the power of minus 4 meter square. Okay, and are separated by a distance. So distance value they have given, that is 3 millimeter. So it can be written as 3 into 10 to the power of minus 3 meter. Okay, and it is connected into a 400 volt supply. So V value is 400 volt. Okay, and here A question they are asking, so calculate the electrostatic energy stored in the capacitor. Okay, so this is the A question, and the B question is, if the dielectric constant of 2.5 is introduced between the plates of the capacitor, find the electrostatic energy stored and also change in energy stored. Okay, so initially for the A question I need to calculate energy stored E or U is equal to question mark, and the B question, so if the dielectric constant is introduced between the plates, find the electrostatic energy. So I need to calculate electrostatic energy, so I will write it as E dash and change in energy delta E. Okay, so initially, so what is the electrostatic energy? So energy expression we know that. So what is energy expression? So I will take it as E or U. You can write E also or U also. So E is equal to half C V square. Okay, so here C value I don't know, I need to calculate C. So C value, C formula is C is equal to A epsilon naught divided by so D. Okay, so what is A? So A is 100 into 10 to the power of minus 4 into epsilon naught value is 8.854 into 10 to the power of minus 12. So divided by, so D value, what is D value? So 3 into 10 to the power of minus 3. Okay, so C value, if you simplify all the terms, so C value will get, so 29, so 29.51 into 10 to the power of minus 12 farad. This is the required C value. Now substitute here. So E is equal to, so half into, so C means, so 29.51 into 10 to the power of minus 12 into V square. What is V square? So V is 400 square. Okay, so that is E is equal to half into 29.51 into 10 to the power of minus 12 into, so 400 square means 4 4s are 16,000. Here 2 1s are 2 8s are. Okay, so if you simplify this one, E1 value, so E1 value if you simplify, so you will get, so 2.36, so 2.36 into 10 to the power of minus 6 farad. Okay, so this is E1, or you can take U. Okay, now we got the E1. Now second question is, if the dielectric constant, so K value they have given, dielectric constant K value is 2.56. so C dash, so I will write C dash becomes dielectric constant times of C. Okay, so what is K value? So K value is 2.5 into C. So C value is 29.51 into 10 to the power of minus 12. Okay, so if you simplify this one, so you will get, so 73.1 into 10 to the power of minus 12 farad. This one is C dash value. Okay, so now next one, find the electrostatic energy. Another energy I need to calculate. Okay, so here another energy I need to calculate. So that's why I will write it as E2. Okay, so E2, so that is equal to half, here I have already taken C, so that's why here, so C dash V square. So that is equal to half into, what is the value of C dash? Half into 73.7 into 10 to the power of minus 12 into V square means again 16,000. Okay, so here 2 1s are 2 8s are. So if you simplify this one, so E1 E2, so we will get, so 5.9 into 10 to the power of minus 6 joule. Okay, So this is the answer. Next one, also change in the energy stored. Change in the energy stored means delta E I need to calculate. Okay, so delta E means I need to minus, so E1 minus E2. Okay, so this one is E1 and E2. So I will write E2 minus E1, larger value minus smaller value. So what is larger value? 5.9 into 10 to the power of minus 6 minus E1 value is so 2.36 into 10 to the power of minus 6. Okay, so delta E value, so if you calculate this one, you will get 3.54 into 10 to the power of minus 6 joule. Okay, or it can also be written as, so delta E is equal to 3.54 micro joule. Micro value is 10 power minus 6.